Welcome to today's class. Today's topic is pair of linear equation in two variable. Before going to this, we have to learn some basic. Okay, no? So, what is equation? What is linear equation? What is linear equation in one variable? What is linear equation in two variable? These are all we learned in the previous classes also. For quick revise. Okay, no? So, suppose 2x plus 6. Okay, no? I'll take 2x plus 6. What is this? Is it an equation? No. Okay, no. Here x is the variable, 2 and 6 are the constant. Then what it is? It is not an equation. Then what it is? Okay, no. 2x plus 6 is what? This is expression. Okay, no. This is expression. Then what is the equation? If expression involves equal sign, I'll take same expression and I'll write equals to 0. If expression involves equal sign, then this is called equation. What is this? Equation. Okay, no? So this is an equation. I already said here x is the variable. The power of the variable. Okay, no? The power of the variable is 1. Okay, no? Then such type of equations we are calling as linear equations. So we can take this one as an example for linear equation. Okay, here two things are there again. Linear equation in one variable or two variables. Okay, no, that depends on the number of variables which are present in the equation. Here only one variable is present. So this is an example for linear equation in one variable. Then what will be the linear equation in two variable? I will take some other example. 4x plus 3y plus 5 is equals to 0. Just look at the equation. Okay, now here x and y are the two variables. The power of the variable is what? 1. Correct or not? So this is an example for linear equation. Linear equation in two variable. Linear equation in two variables. This is example for linear equation in two variables. So let us come back to our concept. What is our concept is pair of linear equation in two variables. Just you look at the word pair. Pair means what? Two. Correct or not? So if two linear equations in two variable, if you are considering that type of equations, we are calling as pair of linear equations in two variables. The first thing we will learn the general form of this pair of linear equation in two variable. So how will be the general form? I'll write the general form. Okay. What? General form. Okay. No? General form. So how will be the general form of pair of linear equation? Like this. a1x plus b1y plus c1 is equals to 0. a2x plus b2y plus c2 is equals to 0. Where a1, b1, c1, a2, b2 and c2 belongs to real numbers and a1 square plus b1 square is not equals to 0. a2 square plus b2 square is not equals to 0. This is the complete form of the general form of pair of linear equation in two variable. These are the conditions you have to mention. If not, means you can't say these two are the pair of linear equations. Why? Because if they are not belongs to real number, if they are belongs to complex, means again it will be different case. Okay, those are all we will learn. Clear or not? This is the general form of pair of linear equations in two variables. So next thing is what? Solutions. Okay, so how to find the solutions for these type of equations? Okay, no, in the previous classes we already learned how to find the solution for linear equation in one variable and linear equation in two variables. Now how to find the solution for the pair of linear equations in two variables? There are two things are there. The first one is what? Algebraic method. The second one is what? Geometrical method, nothing but a graphical method. So first we'll go to the graphical method. Okay. So the first one is what? Graphical method. Okay, now graphical method. So how will be the solutions? Okay, now how will be the graph of these pair of linear equations? Means there will be three types. Okay, now there will be three types. How means the first one is what? This is what? X-axis and y-axis. Negative x-axis, negative y-axis, and the origin. Okay, in the same manner I'll write for all the three cases: x-axis, y-axis. Okay, negative y-axis, negative x-axis, and the origin. X, y, negative y, negative x-axis, and the origin. So the graph of the pair of linear equation. First graph will be like this. This is one example. Just I am considering one example. Okay, now the two. This is graph for the first equation. This is graph for the second equation. Maybe one example. Okay, now the two lines are intersecting at one point. The two lines are meeting at one point. Then this type we are calling as what? Intersecting lines. Okay, now means there will be one common solutions. Okay, now and one more thing is what? Okay, now two lines are overlapping one on the other. Okay, now this one you can call it as line 1. This one you can call it as line 2. Okay, this is another type of solution. One is what? The two lines may intersect at one point. Okay, the two lines may intersect infinite times. Okay, one line, it is looking like a one line only, but one on the other two lines are there. Okay, like L1 is the graph of the first equation, L2 is the graph of the second equation. Here written L1, L2. Okay, this type of solutions we are saying as coincident. Okay, what is the coincident lines? Okay, coincident lines. So the last one is what? Okay, the last one is what? Maybe the two lines L1 and L2 are parallel. Parallel means what? Up to infinite, from negative infinity to positive infinity. They are never intersecting. They are not intersecting at all. Maybe at one time or infinite time. Okay, they are not meeting at all. Okay, then this type of parallel lines. Clear or not? So with this we can say how many solutions are there also. You come here. Here how many solutions are there? One solution. Here infinite solution. Here no solution. Is it clear? The graph method, there are three types. One is what? Intersecting, coincident, and the parallel lines. Clear or not?